Today we're going to talk about interpreting algebraic expressions and turning word phrases into numerical expressions for math. To start off, let's look at some of the words we use to describe mathematical operations. In the first column, we see words that represent addition. Some of these you've seen before, such as sum, total, and plus. All of these represent adding numbers together. In the second column, we see words for subtraction. Some of those you've seen before might be take away, difference, minus, or fewer. I'd like to point out a couple of specific words. First of all, less than, and next, left. For example, if you have 2 less than 20, what it's really asking you about is 2 less than 20. So 20 minus 2, which gives you 18. The last one, left, is most commonly used as a subtraction term as well. For example, if you take one number from another number, what you have left is 5. It's saying that if you take, say, 2 from 4, what you have left is 2. So be sure to remember that left and less than also mean subtraction. In the third column we have multiplication, which you have very often seen the word times, product, double, and triple. The word that I really want to point out today is factors. Factors are going to become incredibly important as we study math this year. To remind you, factors of a number are 2 numbers that multiply to give you the original number. For example, the factors of the number 6 are 2 times 3 and 1 times 6. These here are the factors of 6. The last column shows division. And while you've very often seen quotient and average, I do want to remind you about the word per. Per is another word that means division. You see it very often in your car when we talk about miles per hour. That word per refers to that division line. The last thing I want to talk to you about words is not actually on this list, and that's the word is. Is represents an equality symbol in mathematics. In one of these algebraic word expressions, when you see the word is, it's referring to one of several symbols, either the equal sign, less than, greater than, less than or equal to, or greater than or equal to. When you see is all by itself, it's referring to the equal sign. However, when you see is paired with the words less than, more than, or, for example, greater than or equal to, it's referring to one of these inequality symbols. And that's going to be very important as you put together different expressions. So let's look at some examples. Here we see 2 different examples. The top one, 7 times a number, and the bottom, 7 times a number is 42. The first thing I want to point out is that you'll often see this phrase, a number, in any of your problems. What does this mean? Well, a number in this case simply refers to an unknown, or in the case of mathematics, a variable. Very often we're going to represent these unknown numbers with the variables x, y, or z, or occasionally we'll use a, b, or c. So now let's put these different expressions into practice. 7 times a number. We know from our previous screen screen that the word times refers to multiplication. For our purposes today, whenever we talk about a number, we're going to use x. So in this case, 7 times, this will be our multiplication symbol, a number, in this case we're going to use x, gives us 7x. One of the things you'll notice is that I used a dot for our multiplication symbol. Just remember, from here on out in math, we never want to use the x multiplication symbol because it's too easily confused with a variable. Let's look at the bottom and how it's different. We start off with the same basic system, 7 times a number, so we'll add that, 7x. But now we've added something new. We've added the word is. From our previous slide, we know that is represents an equation and an equal sign, so we'll add in that equal sign. And our final line is 42. So we know that 7 times a number is 42, which means in this case that 7 times x equals 42. Here's another example. 2 times the sum of a number and 5. In order to break this down, we really want to think about our order of operations. To remind you, our normal order of operations, you can remember PEMDAS. Remember, PEMDAS stands for parentheses, exponents, multiplication and division, and then addition and subtraction. So we're going to use this as a guide for how to put these problems together. So looking at this, 2 times the sum of a number and 5, we're going to start by grouping things that would be found in parentheses. In this case, the sum of a number and 5 would be found in parentheses. So we'll write that down. So as you can see, we've created a set of parentheses that represents a number, x, the sum, which is our plus, and of course the number 5. So these three things come together to create the sum of a number and 5. Next, we're going to look at the rest of the problem. It starts out with 2 times. Since times means multiplication, it means we need to multiply this parenthesis set of x plus 5 by 2. And there's our final answer. This next problem is a number plus 5 is less than another number. This has a few interesting pieces. So let's start by grouping. In the beginning we have a number plus 5. So there's the first of our sets. And let's write that down. The next piece of our problem is this central area, is less than. If you recall, back when we talked about words and their mathematical meanings, we determined that the word is has to do with equality symbols. In this case, because is paired with less than, what it's actually asking us for is the less than symbol. Instead of equals, we're saying that x plus 5 is less than, in this case, another number. This is where it gets really interesting. While we do start out with a number plus 5, now we're talking about another number. Whenever one of these problems talks about another number, it means that we're going to have to use a variable that is different than our original variable. Since I've already used x here, we're going to change and we're going to use y to represent another number. So in this case, a number plus 5 is less than another number becomes x plus 5 is less than y. Our next problem is 2 less than 6 times y. In this case, we're going to again refer back to PEMDAS. 2 less than 6 times y. We know from our words that less than means subtraction, and times represents multiplication. So we'll start by dealing with our multiplication. 6 times y can be represented as 6y. Looking at the beginning of the problem, 2 less than, we know that less than means subtraction. Since it's less than 6 times y, it means that we're going to take away or remove this 2 from 6 times y. So our final result will be 6y minus 2. The quotient of a number and 12 is the sum of a number and 2 multiplied by 4. Once again, let's break this into pieces. To start off, let's look at the starting portion. The quotient of a number and 12 is our first piece. Since quotient means division, we're going to divide the two numbers. When given a verbal phrase and quotient, you're generally going to take the first number and divide it by the second number. In this case, the result will be x divided by 12. Our next piece of the puzzle is the word is. We know that is represents an equality symbol, and since it's is all by itself, we know that the resulting equality symbol is simply the equal sign. Next up, we have to look at the final portion, the sum of a number and 2 multiplied by 4. So once again, going back to PEMDAS, we want to break it into pieces. The sum of a number and 2 is something that's going to go in parentheses. So we'll have x plus 2. Since it is simply a number and not a different number or another number as shown in the previous problems, we're still using x. The final portion is multiplied by 4. It straight says that it's multiplication, so we're going to add our 4 in front of our parentheses. Remember, our coefficients go in front of the parentheses, not behind. So that's it for talking about interpreting algebraic expressions. The big keys are to remember to break the problems down. You want to separate out each piece and look at how they all work together. You want to look for is, because is going to tell you what kind of equality symbol goes in the middle. And remember, if there is not an is in the phrase, it's not an equation, but an expression.